In this video, we want to prove that log base 4 of 18 is an irrational number. We know that 18 can be rewritten as 2 times 9. So this is the same thing as saying log base 4 of 2 times 9. And using the log properties, it's log base 4 of 2 plus log base 4 of 9. Now I can rewrite 2 as just 4 to the 1/2 power, or square root of 4. The 1/2 comes out in front, and we're just left with log base 4 of 4, and that's just going to be just 1. So it's 1/2 times 1 gives us 1/2. Now we want to work with log base 4 of 9, and we know that 4 is 2 squared and 9 is 3 squared. So the 2's are going to cancel the exponents, because let's assume that log base 4 of 9 is equal to x. We have 4 to the x is equal to 9. 4 to the x is 2 squared raised to the x power, which is really 2 raised to 2x power. And then 9 is 3 squared. Now if I take the square root of both sides, it's just going to be 2 to the x is equal to 3, which this can be rewritten as log base 2 of 3. Okay, so that's why that simplifies. Now we know that 1/2 is a rational number, but we don't know anything about log base 2 of 3. So why don't we assume that it's a rational number? And the question is, do we get a contradiction? Well, if it's a rational number, then by definition, it's equal to p over q, where q is not equal to 0, and p and q are integers. So at this point, we can do 2 raised to p over q is equal to 3. Now if I raise both sides by q, we have 2 to the p is equal to 3 to the q power. We know that this is always going to be even, provided that p is greater than 1. So remember, p here is an integer, or p greater than or equal to 1, sorry. And then q is going to be odd, provided that q is greater than or equal to 0. Right, if it's less than 0, it's going to be a fraction, and I'm not considering that. But basically, when is an even going to equal odd? That never happens. The only time these two are going to be equal is if p and q are 0. Because then you have 2 to the 0 is 1, 3 to the 0 is 1. But note that we said q cannot equal 0. That's a contradiction. So we said q does not equal 0. Therefore, log base 2 of 3 is not a rational number. And hence we say that log base 4 of 18 is irrational, since we said that log base 4 of 18 is equal to 1/2 plus log base 2 of 3. This is rational. And then we're adding an irrational number. So when you add a rational and an irrational, in this case, it's going to be irrational. Okay. And so that completes the proof.